Hi guys, this is the video for section 10.3 to complete our last unit, unit 6, for the course of Math 107. Let's start with the screen share. Okay. So as you know, chapter 10 has been about statistics and dealing with how do we interpret data, how to gather data sets, and how to understand and evaluate that data in a manner in which we can pull out all the necessary and important information, understand it correctly and in the proper context. This section primarily, as you can tell by the title of the notes, focuses on the things that can be done that mislead you when you are receiving statistical analysis of a data set. In particular, how the visuals that we use, particularly to report and analyze data, that is graphs, charts, can be manipulated either purposefully or inadvertently in such a way that it actually misleads you in your interpreting of the information that's being given to you. Okay, so we're going to start with topic 1, misleading graphs. Now, the thing that you need to note here, okay, so please note that part of analyzing, and I'm going to go ahead and underline that right there, part of analyzing and interpreting data is to carefully look at and consider how the data is being presented. I'm going to go ahead and highlight that part again. How the data is being presented, okay? That is the graph that you're looking at, the pie chart that you're looking at, the histogram that you're looking at, okay? And we're going to look at the various ways in which that can happen. As you can see here, when some aspects of the graph are distorted, then it results in a misleading graph. So what results in a misleading graph? I'm going to highlight that for you. When aspects of the graph are distorted, that is what creates the misleading graph. So parts of it, it doesn't even have to be the entirety of the graph. It does not necessarily have anything to do with the data that's being reported. It could just be a part of that particular graph, pie chart, histogram, line chart, leaf and stem plot, whichever visual representation and analysis of the data that you're looking at. If there's a part of it that's being distorted, that creates a graph that overall is misleading and does not give you accurate information. So the first example that we're going to look at is scaling and manipulation of the axis. Okay, so scaling and axis manipulation. This is easiest to see in bar graphs. So those are the examples we're going to look at. Okay, now what is scaling and manipulation? It is when you adjust the scale on the axes in such a way that it influences the appearance of the graph. Okay, it can be manipulated by the following ways. So you can notice here that there are two ways that we discuss on how we can manipulate it. You can expand that graph. Let me get that. There we go. Thank you. You can expand that scale, or you can contract the scale or the size between the intervals. Okay. Or you can show only a portion of the axis so that you only show the part that's interesting to you. For example, okay, in your textbook, and I'm going to show you those graphs in a minute, but in your textbook, you're going to see that there was two graphs that talked about puffed oats cereal and whether or not it was a healthy cereal for children. And you're going to see that there's a graph on page 461, and it's graph 10.34 that is misleading, and you're going to see that the graph on page 461, graph 10.35, is actually more accurate. Okay, now here are those graphs right here. So here's 10.34. Let me slide it over so you can see it. Okay, this is the one that's misleading, so we're going to go ahead and label that. This one is the misleading one. Okay, and this one, the one on 10.35, hold on, let me erase that here. This is the misleading one, sorry. The 10.34, This is the one that's misleading. Okay. And this one, the 1035, is the one that's more accurate. Okay. Let's look and compare. They're both giving you the same information about the gram of sugar in different types of puffed oat cereals. Each cereal, for the purposes of this graph, has been labeled by a letter. So we've got cereal A, B, C, D, and then the one we're looking at, which is puffed oats. Now, on this graph, clearly puffed oats has the least amount of grams of sugar. So it must be the healthiest, right? That's what they're trying to get you to come to. However, when you look at the more accurate one, you notice that yes, it does have the least, but not by that much. Okay? The difference between it and the next guy up that is being considered as not healthy is only 2 grams of sugar from 10 to 12. Okay? So this graph is misleading because it makes it seem like this is radically healthier when in reality it is not. One of the ways they accomplish that is you'll notice there is no scale here. So you have no idea how to interpret what the distance between these hash marks means. Okay? But clearly, if the difference between here and here is only 2, okay, then this is 10, this is 12. So what happened to the beginning part of our scale, right? What you can see here, here's where it starts, the beginning part. So it is misleading because they are manipulating the scale, okay? Now you can practice, and here on this video, I'm going to show you these and you can go ahead and practice yourself. Okay, if you take a look at this graph on your textbook and this one, see if you can determine what is being manipulated on it. Okay, and these are the graphs right here, the ones that they're telling you to look at. Can you look at these graphs? Okay, here's graph 1036, here's graph 1037, and graph 1038. And if you look here, okay, we are looking at 1036, 1037. See if you can determine what's being manipulated. What you should notice is that the scale and the axes are being manipulated, okay? And again, I'm going to go ahead and give you a minute by pausing. We're looking at this graph, and this graph. And see if you can explain what is being manipulated in both the scale or the axes to give you a misinterpretation of the data that you're looking at, okay? Like I said, what you should notice is that it is the scale and the axes that's being manipulated in those, okay? But this is for you to practice. Now, let's move on to line graphs, because there are other things that can be done to manipulate the data or that graph to give you a misleading graph. All right, so we're going to look at line graphs. Now, line graphs, an easy way to manipulate it here is, again, we're still looking at the scale and axis. This also applies here, so that's why you see that there. Okay. However, they want you to see that it's oh, please don't crash, please don't crash. Thank you. It says you can see that it's less manipulated to show trends, okay? And these are the graphs that we're going to look at. So we're going to look at 2 graphs. We're going to look at graph and figure 10.7, which is on page 423. This is the one that's less manipulated. And we're going to look at the graph in figure 10.40, which is on page 464. This one's the one that's more manipulated because the union is using this graph with the same information that's available to the administration of a particular school district to argue that teachers should get paid more, okay? Now, this is what's being manipulated, but we're going to come back and look at that in a minute. So here are the graphs we're talking about. So This one, I'm going to open it up. There you go. This one right here is the manipulated graph, okay? I'm going to label it with an M. This is the one that's being manipulated. This graph, I'm sorry, rather, this is not the one that's being manipulated. This is the one, oh, please don't crash. Please don't crash. Fingers crossed, guys. Fingers crossed. Oh, come on. There we go. Whew. Oh, this is ridiculous. Oh, of course it crashed. Sorry, guys. This is so frustrating. All right. Let's see if I'm going to stop the share and see if I can reopen it again. If not, I can try and use a different method, as nice, which I apologize for that. But let's see what I can do here. Oh, apologies, guys. Apologies. All right, I'm going to share my desktop. Here's the same notes. Like I said, it's just not going to be as easy to work with as if we were able to use the iPad. All right. Okay, so if we look here, all right, there we go. This is the graph. This one right here is the graph that's not being manipulated. And let's see if I can zoom this in so that you can see it better. All right, so this is the one that's not being manipulated, and the reason why it's not being manipulated, and see if I can draw. Here we go. All right, guys, it's not going to be as nice, but hopefully we can still make it work. So this is the good graph. This is the graph that is doing just fine because it is showing you, and although this here, by the way, this is a symbol, and I'm going to highlight that for you. This symbol right here means that it is compressed. In other words, they know that they started at 0 and the first hash mark you're seeing is 47,000, and you'll notice that the one after that is 49,000, so they're really going up by 2,000. But because the first basic salary starts at 49,000, they have compressed the scale so as not to show you 0 through 45,000 because there's no data there, but not because they're trying to manipulate it, okay? By the fact that they're telling you that the scale has been compressed, it is them being forthwith and telling you that it's not being manipulated, okay? So that being said, you can see the scale is going up by 2,000 apiece, and they're showing you how the salary has been increasing from the year 2005 to the year 2011. Now, that means in 2005, in this particular school district, the average teacher salary was about 47,000, and in the year 2011, the average salary for a school teacher is 57,000. Now, that's not a whole lot of increase, and it's also not the highest of salaries. $57,000 a year in 2011 was not what you would call a great salary. It's not a bad salary, but you would probably still need assistance to make all your ends meet because of inflation and the cost of living. But this is a relatively accurate chart, line graph that we're looking at. And this would be the one that the administration of the district is being used. Now, the union, which is trying to argue the teachers need to be paid more, uses the same data, and they start out by trying to be forthwith, and they tell you once again that they've compressed their scale. However, look at how they are counting. They are counting by 10,000 every time. By doing this, you'll notice that the increase is actually barely noticeable at all. It almost looks like a flat line. So their argument is the salaries have barely been raised, but they're doing this by manipulating the scale in such a way that it makes their graph appear as if it's barely increased at all, versus the more accurate graph that shows that, yes, it's still not a great increase, but it has indeed increased over the course of the years. Okay, so that is what you can see here is what's happening, and they have done this by extending the scale vertically and using larger increments. That is what this manipulated version of the graph was doing. They extended the scale vertically by making the jumps between hash marks a lot larger. And they also used larger increments. So by doing that, they created this sort of flattening of the data, which makes it seem as if no change has barely occurred, when in reality, there is change. It's still arguable necessary to pay teachers more, but there is more change than this manipulated graph is showing, okay? Now, another way that you can manipulate graphs, we said that scale and axes applied here to line graphs too, just like we saw earlier with bar graphs. Another way that they can be manipulated is by using cropping, okay? Now, cropping means that you are choosing the window in which you're going to view the data. In other words, you're not giving the full picture, you zoom in the part that suits your argument, okay? And this is, again, very misleading. And we can see examples of that here in these graphs, okay? If you look here, you can see that we have graph 10.42, 10.43, and 10.44. All of them can be found on pages 466 and 465. Okay, and they are choosing the windows. And let me show you those graphs right here. Okay, this is all three graphs are showing you the same data, but notice how it's misleading because of the window that you're shown. Okay, so this graph here, again, this tells you that it's being compressed. Okay, so you can see that they've compressed their scale. The fact that that's there doesn't necessarily mean that it's misleading, okay, because they are telling you. But read your labels. Here's the part that we need to look at. Let's read the labels, okay? These are dates in January. So they're basically giving us information only from January 11th to January 20th. That's barely a 10-day window of data that they're giving us. And they're saying during this time, this is what's happened in change of dollars. There was this increase. You could see that we went up, came down a little bit, plateaued, went all the way up again, came down a little bit, plateaued, and then really skyrocketed. Or at least that is the growth in money that they're trying to get you to see. But again, this is only between the dates of January 11th and 20th. So if you're looking at this, hey, it looks like, yeah, you're making money. Things are going up. You're generally increasing. It looks like you generally are increasing your money. Life is good. But this window is actually this little piece of the chart, okay? And when you put it into the context of looking at it from September to January, what you actually see is that you're sort of in a downward trajectory. Like, yes, there was this little uptick in January, but overall, you're kind of coming down. Money's being lost. Things are not going as great as you would like them to be, okay? And then this is just September to January. If you look here, okay, and we actually see here how they did that whole thing again, where they expanded vertically the scale and increased the increments. This increment here represents from 0 to $20 million, right? If you look here, where once again, they have made the scale smaller, here it's from 100 to 105. So now instead of it being 20, it's 5. And you look at that same information, now this is a much more dramatic drop in the cost of things, or in the money that you're making, or in the price that you're paying, that something is being charged for, okay? So again, all depending on what you're looking at, you can manipulate the information. This looks like, hey, we're doing okay, prices are increasing, or we're making more money. No, you're not. You're actually on the downward scale. This was a slight uptick in January, where you only focused on a 10-day period. When you look at it over a course of 5 months, you see the trend. But if you keep the scale enlarged, it looks like it's a relatively gentle descent. So we're not spiraling out of control. On the other hand, if your argument is that you are spiraling out of control, you change your scale, and now all of a sudden it looks like a real steep descent. So you can see here how just by dealing with the scales and the window you're looking at, once again, you can manipulate your data. Okay, I'm going to let me just handle this like this. There we go. Thank you. Sorry, my apologies. All right, so now the other thing that we can do is what's called a 3D effect, okay? And this is where people like to do this to their graphs because it makes it look nicer. It's more attractive, more eye-catching. However, if you're not careful how you employ that 3D effect, it can actually obscure the true picture of the data that's being presented, okay? So, for example, we're going to look here at these three graphs, 1045, 1046, and 1047. And here are the things that you should note are obscured or difficult to visualize because of the 3D effect that was placed into them. For 1045, you should notice that it's hard to see the exact values that are being represented, okay? And that in 2011, the actual dollar amount is $56,069, but it appears to look like 55. So it's been rounded down. And if we look at 1045, let's go look at it right here. All right, here we go. And we'll zoom it in if we can. Let's see. Come on. Oops. Let's do that. All right, let's see. We can zoom it in. All right, so once again, we're still looking at that same data on the line graph of teacher salary. Now it's been made into a bar graph, and it's been made into a 3D bar graph, okay? In this 3D bar graph, it looks like the salary is increasing rather nicely. This 3D bar graph also makes it seem as if you're increasing by quite a bit. But what you should notice is that here, okay, the actual salary increase was over $56,000, and because of the way it is seen, it's kind of hard to tell. You might guess that this is more like 55,000 when in reality it's nearly 57. Okay, so that's one of the things that you're supposed to notice that's misleading. The other thing you're supposed to notice, okay, is if you look at the next graph we're going to look at, the exact values again are hard to read. And so it's this, even though it's the same data as we're looking at here in 1045, okay? So let's look at it here. This data here, come back here. Where'd you go? There we go. This data here, so this graph and this graph are representing the same data. Once again, because of this 3D effect, it is a little harder to read this. Once again, it's hard to tell where the salary really is in 2011. It also kind of gives it a different feel. It doesn't feel as quite as a steep incline as this one because of the effect that's been used, okay? And it makes the data hard to read. So once again, you can misinterpret it because of the effect. Now, sure, it's appealing visually, but it makes it difficult to read clearly and understand the data clearly as it's being presented to you, okay? And finally, let's look at figure 1047. And what you should notice here is that in 2005, what's representing that looks twice as high, which makes you think that it holds twice the amount of volume and twice the width, which is not really the case. It's actually misleading. And then you're going to notice that in part B, we see no deception and it's actually a more accurate representation, all right? So let's look at that one right here. Okay, so here's part A. From 1990 to 2005, this is supposed to represent, I believe, the metric tons of wheat that was collected, okay? Oh, excuse me. And as you can see, the 3D effect makes the collection of 2005 appear as if it is twice as much, taller, width-wise, height-wise. So you're assuming that it's a whole lot more. But in reality, okay, if you look at it here, it's not twice as much, it's 2 times, okay? So this is misleading because it makes you think that the volume has increased, when in reality, the volume hasn't increased, it's the frequency that has increased. So this is a much more accurate representation because here you can tell that the frequency increased, not necessarily the volume. Here, it makes it look as if it was a much larger increase. because of this difference between the pictures, the 3D pictures that you're looking at. Okay. Let me see if I can get it. All right, so that is something to be aware of when it comes to the 3D. Now we're going to look at circle graphs. Okay. Circle graphs or pie charts are really great because they allow for visual comparisons, and they always, here's the thing that you need to remember, pie charts are always relative comparisons, meaning we're always dealing with percentages, okay? Pie charts, that's how we create them. We create them by talking about percentages and fractional parts. So they can be very useful for that. However, you need to be aware of the following. It does not indicate absolute amounts, okay? Pie charts are great for relative sizes and fractional parts, but they don't generally give you absolute amounts to work with. So you need to be aware of that, okay? So we're gonna look at a pie chart in figure 10.48. But what you need to remember is they're using, in this pie chart, they're using what's called a method called explode. Ooh, let's fix that, shall we? Where what they do is they make a part of the chart move away, okay? Sort of to emphasize what's happening with that part. And by doing this, it makes it look bigger than it is and misleads you. Now you're gonna see that in figure 10.4.9. But let's go ahead and look at figure 10.4.8 so that you get an idea of what we're talking about. So here it is. This is a pie chart of the vitamins that can be found in cereals. This is a regular pie chart, and you need to understand that this represents percentages, relative. So without further information, this can be misleading because you don't know what percentages these are. Okay, and in relative to what? What is it being compared to? Now here is where they're using the explode. Here is the regular chart. Now here they did the explosion and they separated these two. And now all of a sudden this piece here looks larger than it is, because if you see it here where it's connected, it's just slightly more than about a third, okay? Just slightly more, just this little extra piece more of a third, okay? That's really the difference between the yellow and the other two colors. But when you explode it out, now it looks like it's almost a half of the chart, okay? And it's not, it's only a little more than a third, okay? Here in this 3D version, and they've done the explosion again, it's still, because it's in 3D and because they've done the explosion, once again, it's a little misleading. It appears as if this is half of the chart, when in reality, when you look at the more accurate version, which is this one here, it's only slightly more than a third, okay? So that is something to be borne in mind when you're looking at these kinds of charts, okay? Now, did we ever get to see 10.48? Yes, and this we talked about 10.48. Sorry, thank you. Now, the last thing that can be very deceptive is when you're talking about pictorial embellishments. Now, this is where they try to get really creative with the charts. Not only do they try to make it look 3D, not only do they try to get it to sort of pop out of the paper, but now they try to use sort of like a picture representation of the graph. And what actually ends up happening when that is that it can lead to confusion or be deceptive. So we're going to look at two examples of that, figure 10.52 and figure 10.55. Okay, one of them, you need to pay attention to the nozzle portion of the graph, okay? And the other one, we're going to see how it exaggerates the height, okay? So let's look at that. If you look here, this is what's called a pictorially enhanced graph, okay? You'll notice that this is supposed to tell you about the international cost of gasoline prices. And here we have Venezuela, okay, at 12 cents. Here we have the average US cost of $3.18. And then this is kind of hard to see, but this is in the Netherlands and it's like $8.93, okay? But because they have added to it the little nozzle with the oil drop, it actually really exaggerates the difference here, and it makes it seem as if in the Netherlands the cost is astronomically higher. When you compare the numbers, it is more, but it is not astronomically higher. So this nozzle, because of they trying to make it look like it's the gas pump thing, actually enhances the size of it and makes it seem bigger than it is. Then the other thing here is they're trying to talk about the number of midwife attended births, right? And they're talking about where it was in 1975 and where it is in 1991. And because they're trying to do this idea of the arms of the midwife reaching the baby, it actually makes the distance seem so large that it might mislead you to think that we're talking about a huge change in things. And although it is a significant change, you can see here, this was a number here and this is a number there. This distance kind of just increases it visually and can mislead you into thinking that it's a lot more, it's an exaggerated increase than what it actually is. So you have to look out for these sort of like pictorial embellishments that could particularly mislead you. You have to look carefully at the data being represented and make sure that the picture itself doesn't distort it for you and make it seem more than it is. Okay. Finally, there is such a thing as what's called sampling bias. Okay. And the definition of sampling bias is a flaw in the procedure that makes the sample that you're using not representative of the population that you're hoping to get data on. Okay. The population that you're getting data on is the group that you're hoping to get information about in a sample, and because the sample should be representative of that group, what you see in the sample, you can then extrapolate as being true for the entire population. For example, if I, like we just did with the elections, if I want to know how people are going to vote for a particular candidate, then, obviously I can't ask every single person that votes who they will vote for and why. But what I can do is, if I assume that I know in a particular area that we have a population that has certain aspects to it, if I get a sample of that population, maybe 1,000 people, maybe 2,500 people, and I make sure that that sample has about the same number of women and men and young people and elderly and LGBTQ and African American and ethnically diverse as the actual population of that area really is, then when I talk to that 1,000 or that 2,500 group of people, their answers to my questions could be representative of what I could expect to hear from everybody living in that area. So everybody living in that area would be the population. That 2,500 group of people that I talked to would be my sample. And if my sample is representative of the population, then the information I get from my sample can accurately help me predict what I can expect the whole population to do. But if there is a flaw in the procedure of how you choose your sample, so that you end up with a sample that's not really representative or true representation of the population that you're looking to be able to make predictions about, then that skews your information. And a good example of it, and it's actually my favorite example, is the Roosevelt election, which is where Gallup polls got started because there was a gentleman named Mr. Gallup, and he is the first. He undertook it upon himself to take a poll of how people were voting, and he did this versus a magazine that at the time was a very prestigious, well-known, and wealthy magazine, and they were able to ask many more people than Mr. Gallup was able to ask. So the magazine was able to ask thousands and thousands and thousands and thousands of people about who they thought they would vote for in the Roosevelt election. Mr. Gallup had a smaller number of people that he asked. He still asked several thousand, but his group of people was much less in comparison to the magazine. Now, the magazine contacted all the people that they wanted to contact in regards to whether or not they were voting and who they would vote for in the Roosevelt election by choosing people who owned vehicles and people who had phones in their homes. And that's how they contacted them. Now, in the time of Roosevelt, there were phones and there were cars, but at that time, it was not something that was widely had. Not every household had a telephone, and not every household had a car. Only higher income families, wealthier families, families living closer to metropolitan areas would have had vehicles and would have had telephones and would have had the money to purchase this magazine. And that is what the magazine neglected to realize. On the other hand, Mr. Gallup went around and actually asked door to door a certain neighborhood where he got to speak to the people who didn't necessarily have vehicles, didn't necessarily have telephones, but were also planning to vote, more your blue collar workers. And when he got his data, he reported that Roosevelt would win by a landslide. The magazine, on the other hand, said, nope, Roosevelt's not going to win. The other guy's going to win. And it turned out that Mr. Gallup was correct. And the magazine couldn't understand, how did this happen? How was he right and we were so wrong? Well, because the magazine neglected to take note of the fact that the way they had collected their sample was biased towards people who were wealthier, had money, and could afford such things as cars and phones. Whereas Mr. Gallup had asked a wider range of people that included voters who may not necessarily have a car or a phone and therefore would never have been asked by the magazine. So that was a flaw in the procedure of how the sample was made, and that is what caused the big difference between the Gallup poll and the magazine and what they predicted would happen in the Roosevelt election. Okay, so here are some things for you to remember, and this is important. Things that can cause bias in your sample data. First things first, the number of sample. If you're looking to make predictions on a large population, then you have to have a large sample. If I, for example, want to make a prediction about all the women in Dutchess County between the ages of 18 and 35 and how they're going to feel about a particular topic, I can't just ask 15 women. I can't just ask 20 women or even 100 women. I need to ask thousands of women, because in Dutchess County, we maybe have 60, 70, 80, 100,000 women that live here. And my sample has to be representative of the number of women who are actually in this area. So the number of your sample is important. The smaller your sample is, the less likely that it is an accurate representation of the population that you're hoping to predict information on. The next thing you have to notice is how the participants are chosen. You want to be able to choose people or participants in like your surveys or in your polls randomly. As you saw in the example of the Roosevelt election, if you don't choose them randomly, if you choose them based on something that particularly could make it biased so that you're not getting a representative sample, it can skew your results. So you also don't want, for example, people who volunteer to take these polls, because as a general rule, people who say, oh yes, I want to tell you how I think and feel about this topic that you're trying to get information on, you're going to get biased information, because there will be people who have thoughts and opinions about that topic that maybe don't necessarily feel the need to volunteer to tell you about it. So generally, people who self-nominate themselves, getting people in that way is not your most accurate way of getting participants in a data to get information for a data set. You also want to look at how the questions are asked. For example, you cannot skew your questions so that they kind of lead the person to think one thing or another. You can say something like, which candidate would you like to vote for and why? That's a very non-biased question. But if you say something like, are you going to vote for candidate A, who's looking to do wonderful things for our community, or are you going to go vote for candidate B, who is horrible and terrible and he would never do anything good for us? Well, by the way you're asking the question, you are already skewing how you hope the question to be answered, and that creates a bias. So you have to be careful about how those questions are asked. And finally, as I mentioned before, in how your participants are chosen, you want random versus self-volunteered, okay? You want just a random grouping of people who are representative of your sample. You don't want people who will volunteer themselves, because then they have an agenda that they want to put out there, and you're not going to get unbiased data, okay? All right, so that being said, that concludes, and I'm going to stop my share here, that concludes the video of the notes for section 10.3, which concludes our chapter 10. The homework is homework number 24. It's already posted on tasks, and it will be due Wednesday before 1 p.m. At 1 p.m., we will have the chapter 10 test go live. You will be given 2 hours to complete it like usual between 10 and 3. And then we will discuss the test in our live Zoom class on Friday. All right, guys, have a great day.